Hello everyone, welcome to the new tutorial. This is the last project on data science classification part, classification project, and then after that we're going to start the data science regression projects like stock market prediction, and then from September we are going to have machine learning from scratch series. Okay, this is last project on data science classification, at least this year. Okay, maybe next year I'll do more, but this year. So we have a problem of machine learning classification project finding donors for charity. This project I opted from a Udemy course, okay, and changed it, like added grid search CV and all, okay, hyper tuning. I'll tell you what is hyper tuning and all. So we have a data set of people we approached for donors for our election campaign, okay. We have their education, job, income and ethnicity and other things. We know high income earners are better to approach for political donation, okay. So basically we have a data set and we have a problem to target those people who can actually give us charity, okay, because elections are coming and we need money, okay. So I changed some of the things and I added hyper tuning. This project contains hyper tuning. I will tell you what is hyper tuning, means how to improve your model accuracy, okay. First of all, we're gonna import the data set and then we're gonna do some data analysis stuff, okay. This is important. Then some visualization stuff, some feature engineering like this, okay. Model preparation, minimum max scalar. I'll tell you what is this. I'll tell you everything. This project is beginner friendly, just like my other projects, okay. Means I will explain you each line of code, okay. And then label encoding stuff, the one hot encoding. Then we're gonna split, like see, till here our data analysis and feature engineering, feature selections are completed, okay, and feature scaling, everything is done. Then here we're gonna split X-train, X-test, means training and testing data, and then we're gonna use two classifier basically in this project. Decision tree classifier, how I chose minimum sample split 90, maximum depth 11, criterion Guinea, criterion, okay, I hope I'm pronouncing right. I'll explain you what is decision tree classifier and what is logistic regression, but if you go through a little theory of decision tree classifier, you will know what is this, what is maximum depth and what are they, okay. You just need to watch a theory of decision tree and nothing else. And how I chose them, it's after doing this hyper tuning parameters, okay. Now what is grid search CV, means basically grid search is hyper tuning. I will explain you what is hyper tuning. I will explain you what is this CV, means cross validation, basically k-fold, okay. I'll explain you this and how I got this parameter, okay, like this, okay, best parameters like this, okay. So I'll explain you that also, means how to increase your accuracy, means how to increase the accuracy of the model by hyper tuning. Hyper tuning just basically you just tune your model, means you just experiment with the parameters to get the best parameter to increase the accuracy, okay. I'm going to explain everything. Logistic regression, I'm going to explain what is logistic regression, and then do watch a theory of logistic regression to know what is the solver of Newton, means what is solver, what is C, okay. So we're gonna train on this, and how I chose this C100 is basically after training and testing I applied the hyper tuning method. I experimented it with different parameters to get the best parameter to train, okay. And I'll explain you how to hyper tune your logistic regression model, and then we got the best parameter, okay. And we got little bit increase in accuracy of logistic regression by applying grid search CV, okay. That is our hyper tuning parameter, hyper tuning method. So I'm gonna explain each thing, okay. If you found this video useful, you can like this video, okay, so that you know it will boost the engagement. And if you have any doubt, then comment down, okay. Okay, so this project is very beginner friendly. Let's start. Okay, so let's start the coding. First of all, I'm gonna import, of course, pandas as pd. Why? Because pandas is used to read data from CSV files, Excel files, and everything, and you can play with it. Okay, and where is our data? Where is our file name? Basically this adult.data. Okay, let me import it, and you will see then slash put r here. And why r? Because Python takes everything in the forward slash, so you got to put r to make everything like reverse. You have like right now backward slash and adult.data. Adult.data. Okay. Now what you need to do is just what is your data frame? df is equals to pd dot read csv. That's how you're gonna read this. Okay, dot data thing or data file, read csv file name. Okay, see, okay, it is imported and had means it will only show you top 5. Okay, see, the data is very messy right now. Okay, the data is very messy right now. See, 39 should be here. Okay, it should be something age here. Okay, job and something like what do you say, status, like if you're single or divorced or married. Okay, what is your color? So it should be like that, but right now the data is very messy. So let's fix this. Okay, so see, okay, I have stored everything. See, I have stored everything right here. Like what we need to fix is this. Okay, you can just right now pause this video and you can write like this. And what we just need to do is basically we just need to copy paste this here. Column names is equals to age, work, class. Okay, and this you can say the ID number types. Okay, education number, and all the other things. Okay, gender, income, and all. So we just need to do like this. Okay, now df is equals to pd dot data frame. We are creating a data frame. Okay, and it's just gonna be df dot values, and what is the column names. We are right now what we are doing is we are editing the column names. Okay, because our data set is very messy. So column, this is name. So what it's gonna do is column is equals to, now column is this. Okay, column names this is, and of course and it is gonna store all these things in this df. Okay, so see, let's I did something module pandas and to data frame. Oh, it's capital there, I think. Okay, now see, see, data set is ready. Age, work, class, and education, everything, range, gender, income. Okay, now the thing is, see, here we have those who earn less than 50,000 and those who earn more than 50,000, right? See, more than 50,000, less than 50,000. So we just need to classify. We just need to predict, or you can say we just need to classify and choose those person who earns more than 50,000, so that they can donate for charity, of course. Okay. Okay, now let's do some data analysis. Okay, little bit. And first of all, let's see what is its shape. Like we can clearly see. Okay, you can even see it like this. df dot shape. Okay, see. 32560 rows and 15 columns we are having right now. Okay, and let's see if it contains any null value. Okay, df dot is null. Am I doing something wrong? Of course, yeah, it is null. I'm sorry. See, false, but between 5 and this 3 to 5 we don't know, right? Of course we can't see, so let's do this. Okay, Now see, no feature contains any null value. Okay, means we summed it up totally, and we are right now saying this. Okay. Okay, now let's see the number of uniques. Okay, u n, then unique. Okay, u n I q u e. See, age is 73 uniques. Feature gender, of course, gender 1 and 2. Oh, sorry, means 0 and 1, male and female. Okay, and 73 age means let's call the age df age. I think yeah. Okay, okay, for 73 and see age. I think minimum value is 27. Let's see now. Can we do it like this? Minimum. Yeah. Okay. See, minimum age means in this data set. Okay, even a person of the age 17 is also included. Okay, and the maximum value, see, maximum 90. Okay, that's why, yeah, total you can say 73 age means the total number, in this data set, how many persons are there? 32,560. You can see if you include 0. Okay, so the variety of ages we are having right now is 73. Okay, from 17 to 90. Okay. Let me from 17 to 90. Okay. Yeah. So income, of course, only two variety we are having, less than 50,000, more than 50,000. Okay. Let's see the information. Age C, no null value means C, 325600. Till here there is no null value. Same C, 32560. Okay, not 00 but 60, non null. But the problem is, okay, you can say they are like object types. Okay, see, age is numerical, right? Age is what? Numerical. If you see here, what? No, don't see here. Okay, age is numerical. Let me just show you how to integer. Okay, or numerical, of course. Let me show you how to convert that. Okay, into their real object type. Okay, so df is equals to, we are storing in data frame, df dot infer objects, and if I just see, okay, now df dot info. See, age is now an integer 64. Earlier it was object. Okay, earlier everything was object. But see, and education number, capital gain, capital loss, income is objective, of course, and this hours per week. Okay, good. This is basically, our data frame believe that, this represent the number of people. But we're gonna drop because we don't need it. Okay, we're gonna drop it later. First of all, after this we're gonna do some more stuffs. Okay, and we are doing right now data analysis, and we're just gonna see the income. Okay, now see income like this. Okay, but there is something like, you can say white space characters can be there. Okay, like it's gonna make our work difficult. Okay, so what we're gonna do is basically df income dot string, not here, dot string dot strip. Okay, okay, like we can't see the difference, but you know, somewhere between this, okay, 4 and this, there might be something like, you know, difference in this, okay, the way they have written. So it will create it would have create, you know, trouble for us. So now let's see again this the total number of records and all, okay. And then we're gonna do our data visualization, okay. df dot shape and records is df dot shape, total number of records, okay. Means, of course, how many people are there, you know, 32560, right? Now we gonna see like how many people earns more than 50,000, right? 50k, and this is like df dot, not df dot, but df, okay, data frame. Under that we are working. So income, and compare, like, of course, those who earn equal to more than 50,000. See, that's where it would have created the problem if you don't do this. Now there might be something like in between, something like this, okay. So it would have taken only this one and it would have left this one in counting, okay. Dot shape 0, okay. Now let's see those who earn less than or, you know, equal to 50,000, and of course we are not going to choose them for the charity. Income, yeah, okay, equals to those who earn less than or equal to 50,000, okay. Dot shape 0, okay. And let's see the percentage of people. That's how you can do data analysis, okay. Means you are just right now doing some basic data exploration. You can even represent this kind of thing to your client, okay. And greater 50k slash and records, and of course into 100. And now you can simply see, sorry, see, there are total this much people, okay, and how many people earn greater than 50,000 is 7841. These are the people whom we're gonna approach for the charity, okay, and these are the people we're gonna ignore, okay. What are the percentage of the people who earn this much? 24% around, okay. So you can even write it like this, okay. Print sorry for the spelling if there is any spelling mistake, making more than 50k, okay. So that you should write it in a better form, of course, okay, to represent if you're gonna represent this to any client sort of thing, okay, because they don't understand the coding, no? So they will understand this only. And dot format means what it's gonna happen is basically see, and greater individuals earning making more than 50,000, okay, and here this value will get stored, okay. Always use dot format thing, okay, so that you can store it like this. here. Okay, individuals making more than this, and similarly you can do right here. Okay, similarly you can do here the number of people, what are their percentage, of course, not for me, less than or equal to 50k. Ranking less than or equal to 50, less than 50k or equal to 50k, 24,719. Okay, even you can write it like this for one. Okay, let's move forward, and now our visualization part. This is, we did data exploration and little bit of data analysis stuff, and data visualization is one of the main part of data analysis. Okay, we're gonna visualize some of the graphs like this. Okay, yeah, we're gonna visualize some of the graphs. Okay, like this visualization. Okay, like this. Okay, and then we're gonna do feature engineering. These are the, and this is our feature engineering, feature scaling. We're gonna do like this, and then we're gonna predict the model, means train our model and predict it. Okay, so first of all we're gonna import Seaborn and Matplotlib. Okay, import Seaborn, that both of them are plotting tools. Okay, visualization tools. You can visualize beautiful graphs from this tool. Lib dot py plot as plt. Okay, so let's have the let's have this graph first of all. Where it is. Okay, not loaded here, but alright. Let me run this one again. Okay, this is just my previous set. Okay, so sns dot set. What we're gonna do is we are going to see the two variables. Okay, together right now. sns dot style is equals to white grid. Okay, just a style and nothing else. Color code. Yes, color code means every variable gonna have their own color. See, we're gonna see this right now. This one. Okay, like the gender and the column and this education. Okay, like see, education, some college education and education of 7th, 8th and all. Okay, okay, I'm going to explain what is this. Okay, visualization is a very important factor in any data science project. Okay, because it comes under your what is, yeah, data analysis. Gender column should be education, and you can know after seeing the visualization you can figure it out, like what which variable, which feature is important and which you need to drop because they are not important. Kind, count. Okay, with income, yes, we're gonna see according to the income. Color code, color codes. Okay, it's color codes. Okay, we have one more thing here, that is column wrap is equals to 4. Let's see now. Okay, see, Okay, what you can visualize with this graph, see, education bachelor, okay, and see first of all, see the gender, it is written, okay, this one is for male, okay, and this one is for female, means this one is for male, this one is for female, okay, and we have given HU is equals to income now, so the color is based on income. Those who earn less than 50,000 has blue color, and those who earn more than 50,000 per month, sorry, per year, is having orange color. Okay, so those who are earning less than or equal to 50,000 per year is having blue color. Okay, see, education bachelors. Okay, first of all, see this one, education bachelors. This one is for male, this one is for female. Okay, so those male who is having bachelor's degree and are earning less than or equal to 50,000, their number is around 1700. Okay, and almost half of the men, okay, of same number, okay, almost half of them, a slightly higher number of men who have bachelor's degree are earning more than 50,000 per year. But when it comes to women, see, their number is very less. Okay, those who are having bachelor degree but earn more than 50,000, their number is very less. And the women who has done bachelor degree but are earning less than or equal to 50,000, their number is like around 1200. Okay. Similarly, you can see for higher high school grade, 11th class. Okay, like see the some college. Some college means some college, any kind of college. See, those men, those men who have done, who have graduated from some college, they are earning less than or equal to 50,000. Their number is about 3,000. Okay, and those are earning more than 50,000 per year. Their number is you can say slightly greater than 1,000. Okay, so slightly greater than 1,000 people, 1,000 men are earning more than 50,000 per year who graduated from some college. Okay, and in the case of women, similarly you can say, okay, around more than 2,600 around women are earning less than or equal to 50,000 per year. And see, their number is very slow here. Okay, almost 200 you can say, earning more than 50,000 per year who has graduated from some college. Okay, so you can visualize this graph like this. Okay, so let's move forward to visualize some 2 to 3 more graphs. df.hist to make histogram. Here we are using pandas function that uses matplotlibs. See, dataframe.hist means dataframe is what? The pandas function. Histogram means under pandas you can even visualize. Okay, you don't need to import matplotlib or seaborn. You can even visualize like this. But pandas function uses matplotlib in the backend. Okay, so they are almost same. Columns. Oops, what is this? Rectangle. See, oops. See, to remove this line, you just need to write plt.show. Okay, and like see, this is like if you do in any simple ID, it will you will understand the difference. But see, now this histogram is under this block. Okay, so see, according to the age, okay, how many people like see age between the minimum age was 17, right? So from 17 to I guess greater than 20, total number of people are almost 5,500. Okay, and around the age of 30, total number of people are you can say 5,800. Okay, both men and women include all. Okay, and from 30 to 40 we have like around 6,000 people. From 40 to 45, 46, 47 you can say we have greater than 6,000. Okay, and see, uh, in the range of 90 we have very low number of people, maybe only 100. Okay, so you can visualize like this. I really recommend you to use Plotly. Okay, Plotly visualization graph, it's easy. You can see my you can watch my COVID-19 data analysis project tutorial. I've used Plotly there. Okay, so see, if you look at our data set, no, um, see, you can visualize any kind of thing, like we just visualize age. Okay, but now the thing is, um, you need to see if there is any null value or not. Okay, in every column, like we have seen, yes, we have seen that there is no null value. Okay, non-null with 32560 non-null. Okay, in everything. But the thing is, sometimes they don't have any blank space, or they have not written nan or null. Okay, sometimes they have written like question mark. I've done this the data analysis of this data set, and see what I found is in the occupation. Okay, in the occupation we have something like this. Okay, if you search for this, no, so if you do that like this, you will find that in the occupation part we have some rows which does just have question mark. Okay, you can do for every class, but of course I have done for see in the native and even the work class. Okay, so what we need to do is basically and we need to drop this one. Okay, first not means because this column, this feature for us is having no use. Okay, so let's just drop this basically. Then we will do something about that occupation thing. Df dot drop. What we need to drop is that fnlwgt axis is equals to from columns we need to drop. Okay, that's for axis 1. Rows is for axis, means axis 0 is for rows. Okay, and this is equal to true. And now if you just in place equals to true to remove it permanently. Okay, so if you see that column there it is, yeah, that this one is removed now. Okay, this one is gone. Now let's do something about that occupation thing. What we can do is basically first of all see df occupation okay, equals to which is having question mark, so we want to just see that. Okay, I think I need to get it is just, yeah. Okay, so see occupation. Okay, and similarly we can see for work class and native country. Okay, if you just give like work class and native country is also having this. Okay, so we just gonna drop those rows. Okay, we're not gonna drop those columns, whole columns. Okay, we're just gonna drop this rows. Okay, so this one is showing right now only those rows which is having question mark in the work class. Okay, especially in the work class, and we can see for native country also. So we gonna drop them now. We're gonna drop only those rows now. Okay, not columns. Okay, so we can drop them easily. df equals to df work class only. See, I will explain you. Okay, not equal to it is space comma. Okay. See, from data frame we are storing only those rows of work class, okay, which is not equal to question mark. So which is not equal to question mark means only those rows will be there which is having some value, okay, and not question mark, and we are storing that in the data frame. Okay, so see, after storing, if you run this cell again, okay, let me run, copy this, and see, now work class is not having any question mark, but occupation is having. Okay, so we will see only those rows in which question mark is there in occupation feature. Okay, so let's drop them like this. Oops, let it be like there, and okay, and for native country also, no, native and this country. And let me store it in a DF again. Okay, so first let's check for occupation. See, occupation not having anything, and native country also. So means, and we have already checked for work class, right? So means now no. Oh. And I forget to I forgot to do that. I need to import this one again, and sorry guys, I forgot to. Yeah, okay. I needed to run this again because I forgot to add this thing again here. Okay, this one, and I was like, boom. Okay, df. Okay, now means I stored everything in this df. Okay, like I mistakenly had double square to here, means df was having everything which is equal to question mark, which was nothing. Okay, so now what df is now df is reduced to, you can say, 30161 rows. Here you can see 32560, okay, 559, but in between we have dropped many rows, so it's now about 30161 rows into 40 columns. Okay, so almost you can say how many columns we have dropped. 2000, okay, more than 2400 rows we have dropped. Okay, so now we have all the cleaned data. Okay, and we're gonna prepare our data for modeling. Okay, and then we're gonna train it with two classifiers right now. Okay, in this tutorial, if you want, I will give you this notebook also, which is having AdaBoost, decision tree, SVC, and I'm gonna use decision tree and logistic regression because I have not used logistic regression and even SVM. But okay, right. Let's prepare this one. So prepare our data for modeling means pre-process. We're gonna pre-process. Okay, pre-processing. Now the thing is, what we're gonna do is basically see, the age difference. The minimum age is 17, the maximum is 90. Okay, the difference is huge. Okay, even in educational number, see the difference between 90 and 7. Okay, difference between 90 and 7 is very huge if you compare age and number. Okay, so what we need to do, we need to scale down these numerical values into a particular range. Their value will not decrease. Okay, we need to scale down between 0 to 1. We are gonna do that. Okay, means if age is 90, their value will be, just for an example, their value will be somewhere around 0.80, 90 or 0. Anything like this. Okay, or even 1. Okay, and if its age or education number is 7 or 17, whatever, then their value, then their number will be somewhere around 0.10, 20. See, their value will not decrease. Okay, their, according to that scale, their value will be seen, just the numbers will be decreased. Why we need to do this? Okay, so their value will not decrease, just the number will decrease, so that model, it will be easy for a model to to calculate. If you are using KNN, then it will be easy for the model to calculate their distance. Okay, I'm not going to use KNN, I'm just going to use decision tree and this your logistic regression. Even for logistic regression, it will be easy for the model to calculate their distance. Okay, so see, if you use KNN, decision tree, see, min-max function is not necessary for decision tree. Okay, scaling is not necessary for decision tree. So what happens is, in KNN, see, if one number is 7 and the number is 90, okay, even if they both earn more than 50,000, but the KNN model will think one number is 7 means their distance is less, another one is 90 means this 90 age, it just doesn't comes under a particular range. Okay, its distance is large, so it is possible that the person who is having age of 90 don't earn 50,000. Okay, yes, it happens. So that's why this 90 age needs to come in a particular range so that KNN can calculate their distance easily. Okay, so it can give a accurate answer. Okay, their value will not decrease, just the numbers will decrease. Okay, now how we need to do is, how we can do. So first of all, like, see, we're gonna use min-max function. Okay, we can use standard normal deviation also. Min-max function, what it do is it scale down the features in a range of 0 to 1. Okay, if you just see now, you can read, it just scale down the function. That's how you apply, and it will scale down this one like this into a range of 0 to 1. Okay, so see, 1 minus 1 to 118, and see. Okay, let's apply this here now. First of all, we need to, from sklearn, we're gonna import pre-processing. From sklearn, see, under pre-processing is under sklearn library. So sklearn dot pre-processing means from sklearn we have pre-processing, and we are importing a class named as min-max scaler, and let's name our scaler something like scaler. Okay, scaler is equals to, that's how we import it, like, see, scaler. Okay, means we are importing this class from here. Okay, and we are naming it scalar variable. Okay, now numerical, we need to scale down the numerical features also, means not also only. Okay, we will come to the categorical features. Okay, like, we will do something about it, but let's do first of numerical, education number. Okay, they are the numerical columns, capital J and capital loss. Okay, let's first see them. Numerical. See. Okay. See their difference. Oh, see 15024. Okay. And 7. And 0 to 1500. 7 to 15024. Sorry. So huge. That's why we will scale down them. Okay. So let's scale down here only. Numerical is equals to scalar dot fit. What dot fit function do is, it used for fit transform, means it will transform this. Okay, transform. What it will transform is see this. Okay, so transform, and let's see. Okay, now let's see df c. Okay, means we transform numerical values of the df. Okay, see, we transform numerical values of the df and stored in the numerical values, of course. Okay, so see the age now. Okay, see the age, and let me call them like this. Okay, see, earlier the earlier the capital gain was around, what was this, 15,000 or something like this. I'm not remembering right now, but see the age 45. Okay, let's see the df. Earlier the df was 15,024. Okay, 15,024. And now see, they have scaled down. Their values have not changed. Okay, this is the numbers have been brought down so that it will be easy for the model to to take the input and to predict. Okay, so now it's time to do something about these categorical values. Okay, because model we did for numericals, we scaled down them. Now it's time for categorical values. Model doesn't take input in a string form. Okay, see, model will take in a numerical form, but it will not take in a string form. Okay, so what we need to do is we need to convert them into numbers, and what we will do, we will just encode them in the numbers. Okay, guys, I forgot to do this for hours per week also. Let's do it for this. No worries. Okay, it has been transformed, and now everything is done. Means 5 features we had to do. Okay, so now this one is done, and see, x for x. Okay, there is 2 variables to like, see, to give model to train, we need x and y. X is ready, y we need to read. That is why we need to ready. That is our target variable. Okay, these are the features. This is our target variable. Y means those who are less than 50,000 or equal to 50,000, exclude them. This is our target variable. So see how we need to do it, like y is equals to df dot income. Okay, so this is our target variable. Okay, now what we need to do is basically we need to remove this from the x. Okay, so df, and how we need to remove this is basically df dot drop income from axis 1 in place is equals to true. Okay, so see, so income has been dropped, and see where is the income right now. Okay, in the y, but this is in a not in a good you can say in a good form. Okay, so what we gonna do is those who earn less than 50,000 will be having number 0, and those who earn more than 50,000 will be having 1. Okay, that's called label encoder. Okay, this is not in integer form. Okay, this is in object form. This is in string form. Okay, so this is in category form. We need to label them. Means we need to numerize them. Okay. So what we gonna do? We gonna apply label encoder to encode them in a number. Okay, 0 and 1. So let's apply label encoder sklearn dot pre-processing. We're gonna apply label encoder. Okay, label encoder and encoder. It's basically label encoder. That's how we call them. Y. We are gonna apply in the y. Y is equals to y dot apply. We're gonna apply the lambda function. Okay, let's see. Let me explain what is lambda function. Lambda, okay, means this x. We are choosing x. You know, like in a for loop for I in y. It's something like this. Okay, means this x will go into y. Okay, this x will go into this y. Okay, and it will convert those if x equals to let's say less than or equal to 50,000, it will convert that into 0, else it will convert that into 1. Okay, and we are storing them into this y. Okay, means this x will go into y, and if x equals to less than 50,000 or equal to 50,000, it will be labeled as 0. Okay, it will encode them into 0, else 1 means only this one. Okay, so else 1. So see, after applying, you will see the difference. Okay, see, earlier it was like this and now it's like this. 0, 1. Okay, means we have encoded this. Okay, we have converted this string form into C. It was object earlier, now it's integer 64. Okay, means we have done label encoding and into this categorical form to convert this into numerical form. Okay, 0 and 1. 0 is for less than or equal to 50,000, 1 is for more than 50,000. Y part is done. Okay, Y part is done. Okay, means for any machine learning, we need Y and X, like target variable and features. So the work of target variable is done. Okay, means we have applied everything whatever we needed, and if we talk about X, we have scaled down our numerical features. Okay, see, only half part is done in the X. Okay, now we need to encode this categorical values also. Okay, because see, of course, as we did in Y, model don't take input, okay, in the categorical form. We need to convert this into numerical form. Okay, so we're gonna apply another method here called one hot encoding. Okay, and you can see the difference between label encoding and one hot encoding. It's your homework. You can check it, like why we are applying one hot encoding here. Basically, you will see. Okay, I'll explain you how to do it. Like, see, df final, or let's name it x. Okay, x equals to means df or not, sorry, pd dot get dummies of df. See, now if I call x, see, earlier it was having 13 columns only, and see 103 columns. Why? Because see, like this. So see, in the work class we were having federal government, local government, private, self-employed, okay, and employed, I think so. Okay, so in the work class we were having total this much amount. Okay, total this much. How many? C self-employed, not INC, private, self-employed, and if you see number of uniques and UNIQE 7. Okay, total 7 we were having. How many total we have right now? 1, 2, 3, 4, 5. Why? Unique. Okay, see. We were having private state government. Why state local government is there? Okay, see. We have this one here right now. Okay. So in the work class, see, total 7 features were there. Okay, means 7 categories were there. So see, we have applied one hot encoding in every feature, of course. So see in the work class, okay. See in the work class for the federal government, okay, for the federal government, those who are working under federal government, according to this data frame, okay. See this data frame, if you see, okay, private, okay, like see those who are working private, okay, they have been categorized into 0 and 1 according to others. Okay, see in the private, who's not working in the private, it has been categorized in 0 and 1 according to other data frames, according to other features. Okay, like see, if I just print the list of x dot columns, so you will see it's like total we have 103 columns. Okay, and see work class, we now have columns this much. Okay, private has been, or you can say work class has been categorized, work class has been encoded, and it has been classified. Work class has been encoded according to other data frames. Similarly, see education columns has been divided, okay, with all its features with 0 and 1. Okay, see we can't see much because see it's under this. Okay, total 103 columns are there. Okay, in the native country, every countryman has been divided like this. Okay, they are the features now, and it has been encoded with 0 and 1. So if you search for what is one hot encoding, you will find. Okay, see, you will find what is one hot encoding. It's like why use one hot encoding allows the representation of categorical data to be more expressive. Many machine learning algorithms cannot work with categorical data directly. Okay, the categories must be converted into numbers. So what it does is basically like this. Okay, apple, okay, 1, 2, 3 calories are like this. Okay, so all the columns like see apple, chicken, broccoli, okay, it will be categorized like this after one hot encoding. Okay, see apple, chicken, broccoli, 1 for see apple is having 95 calories but not 2, 3, 1, 50, so 0, 0. Okay, so apple, you can say for 231 calories, of course it's not true, so 0. 50, does apple have 50 calories? Not true, 0. But apple has 95 calories, so 1. Similarly, chicken is having 231 calories, 1. Other 0, 0. Broccoli is having 50 calories. Okay, so 0, 0 and 1. Similarly, what we did here is basically we did same thing here. Okay, see private. Okay, see though who was working in the private. Okay, those who were having those who were having age 38 educational 9. Okay, like see, one of the person who is having age 38, educational 9, and was having higher school graduate. Okay, and relationship like this and all was working in the private sector. Okay, that person has been encoded with 1. If you okay, see, the first one has been encoded to 1. Okay, but the 0th one has been encoded to 0 because if you look at the 0th column, sorry, 0th row, it was not working in the private sector, it was working in the self-employed. Okay, it was self-employed, not INC. Okay, so in the 0th index you can see that person of having age 50 and this are not working in the private sector. Okay, so see, its private has been turned out to 0. Okay, so that's how one hot encoding works. Okay, and see, now our X is ready and total with 103 features. Okay, now means 103 features, of course. See, total number of rows 30161 after removing those question mark of 3 columns, and we are having 103 columns. Okay, sorry, question mark of 3 rows, 3 columns, and means all the rows, means total 2000 rows, and now we are having 103 columns. Okay, now our y data is ready, means this is our x data. Okay, and our y data is also ready. Both of them are ready to serve the nation. So see, x is totally ready and y is totally ready, and we just need to apply train and split, and then after your machine learning thing. Okay, we means, of course, we have what we have x. Okay, in the another notebook which I have taken, the name of x that person has given is features final and y income. Okay, so we have given name x and y, and we will convert that into training and testing. We will split this data into training testing. Okay, so let's do it. So our x and y is ready. Okay, now let's split them into training and testing. Okay, x train, first of all, how we need to split them is from sklearn dot model selection. Splitting them means into, see, it's 30161 rows. 70% of the rows, okay, you can say we're gonna give it to we're gonna use it for training purpose. Okay, and 30% we're gonna use for testing purpose. You can even split them into 3 different things, 3 different forms: training, validation, and testing. But I'm just gonna split them into training and testing. Import train, okay, train, test, split, and let's split them. X train, first define them x train. Okay, then x test, then y train. Let me explain you what is y. What is y? Y is the labels, right? Y is the labels. So let me show you. Test split x. See, x will be divided into this x train and x test. Okay, 70%, 30%. Y, it's y is the label of x. Okay, means y is, you can say, the target label and or target variable, you can say. Okay, so y will be divided into same 70% and 30% according to this x train. Okay, so what? So this 70% of the x train, its target is this. Okay, so we're gonna train with x train and y train, and then we're gonna test it with x test and its target variable y test. Okay, y test and test size
test size. What is the test size? 0.3. Okay, means 30% we are splitting. Random state means randomly we're gonna put it. Now see. Okay. See, X has the rows of 30161 and X train is having. See, X train has been split it randomly. Okay, see. Now 70% of that is in the X train, and similarly X test. Oops. See, this is X test. We're gonna use this for testing purpose to test our model. See, the rest 30%, 9049 rows, and the target of X train is C 8841. Okay, let me put this one here. 8841 starting. Okay, see 8841. This is for X train. Okay, so this we're gonna use for training, and this is for, of course, training with its target variable. Okay, 7734 7734. Okay, so our X train, X test, Y train, Y test is ready, and let's train it using our first model, that is decision tree classifier. So first model is decision tree classifier, and let me first show you what is decision tree basically, right? What is decision tree? See, it's a very simple classifier. Okay, it's a very simple model. It's just like okay, this one is good enough. Okay, if see, if you want to make a decision, if you want to go by bus, or if you just walk through that path, or you will take a bus, you can train a decision tree, and it will decide whether you should walk or you should take a bus. Okay, if weather is sunny and time is greater than 30 minutes, then you should walk. Okay, if it is less than 30 minutes, if your time is less than 30 minutes, then take the bus. Okay, if it is cloudy and you are hungry, then yes, walk, and if no, then take the bus. And if it's raining, then of course bus. Okay, so decision tree basically just make a tree type structure. Okay, and it take decision based on that. Okay, if something is happening, then do this. If something is not happening, then do this. Okay, so basically what it's gonna do is gonna basically take all these 103 columns. Okay, if age is this, and education number is this, and if that person works on local government, if that person works on private government, then means it will take all 103 columns, and it will just split the data, like if person works in local government, and if his age is this, then go for the charity. Okay, ask for donations, otherwise don't ask. Okay, so how you gonna call the decision tree, right? It's simple. You just need to write from from sklearn.tree. Okay, import decision tree classifier. Okay, now dt equals to, again you just need to copy paste this. That's how you're calling the classifier. Okay, and you're storing in the dt. Now dt dot fit means started training. X train. Okay, this is our training data, right? And y train. That's all. See, training is done, and by default, okay, you can even give your parameters like here. Okay, see, these are the parameters. If you press shift plus tab in Jupyter notebooks, and see, minimum sample split and all. Okay, I'm not doing this. You can do. Okay, random state, maximum leaf nodes and all. Okay, and see, by default minimum split is 2. Okay, and this. Okay, and see, let's test it. Okay, this is our, see, our training is done. Our training is done. Okay, let's test it on the test data and predict, means let's predict it on the test data. Okay, we are testing it on the test data, and then we're gonna compare this with our labels, test labels, prediction. See, okay, first of all, let me go for its score, right? What's score? dt dot score, the training score I wanna see. Okay, the training score. I'm gonna run this one again. Okay, before seeing the training score, I would like to see the training score. Am I doing something wrong? Oh, sorry. Why train? Okay, 98% training score. Okay, and see, then what we did, we this is the model. Okay, this is the trained model, and we predicted it on the X test data, that 30%, rest 30%, and see, this is our prediction. And let me try to say this. And, see, what was our Y test? See, after splitting, what was our Y test? What was our Y train? I showed you, right? The rest 70%, and this was the rest 30%. Okay. See, if you see in this index 27340, what is that? 0. Okay, 000 means that person doesn't earn more than 50,000, you can say, and even say this. Okay, 00, but here see, it is 1, and it is 1 means the X test, the third one, it is showing 1, but in our X test and its label Y test, it is 0. Okay, means what we did is we took our model and we tested on X test, and let's compare it with you can say Y test. Okay, means how we gonna compare it? Like, I just compared manually, but you can compare it like this. Accuracy. Okay, first of all, I need to import accuracy, right? You can import it with from sklearn.matrix import accuracy score. Okay, then you can do it like this. How? Accuracy of decision tree, accuracy score, compare, see, Y test, and compare it with this prediction which we just did. Okay, see, into 100, why? Because of course 200, and let's compare it with accuracy GT, and this is our test score, 81%. Okay, 81% means, of course, which this one misclassified, that was 0. Okay, in the X test, in the third one, that was 0, and it misclassified it as 1. Okay, so there is an error. This is the error. Okay, so means those 19% is the error, but our accuracy is almost 81%. Okay, so we are done this, but okay, now you can manually predict this. Okay, with test data. Okay, we predicted it with test data. See, if it's simple. Okay, let me tell you something. It's simple one. What? X test. Okay, if you simply see now, if you give input if you give your input like this, okay, I'll show you, don't worry. If you give your input like this, age is this and this with all those 103 columns, okay. If you give your input like this, it will predict if you should go for that person or not. It will just simply show you 0 or 1. Okay, let's do it. dt dot predict, and as it is 103 columns, okay, so I'm not gonna write all the features, you know, one by one. I'm just gonna simply do this x test, and the first column I need now. So 0 1. See, the first column, if you just simply call this now, it will be like say this one, okay, and it will just simply show us see 0 means don't go, okay. And in the x test, if you simply see, and in the x test, let's go for the third one, right? Third one, this one, which it misclassified. 90, I hope I'm right. Yeah, okay. In the actual one, okay, we saw now. In the actual one, we saw in the y test, its label is 0, okay, 9084. But here in the third one, okay, you can say it misclassified as 1. So it's probably gonna misclassified here also. Of course, it's gonna misclassified. But sometimes, you know, while teaching someone, it happens. See, okay, array 1. Of course, it's wrong, but see, okay, it misclassified. Of course, we checked it manually, right? So if you give your input like this, okay, or even if you want to give all 103 what do you say, columns, okay, so you can simply give it like, you know, age is 45, so you need to give it on that basis. I think, you know, that we did now min max scalar, so you need to give like 0.45. Then the second feature you need to give whatever it is, okay, like after age, what is it? After age you need to give this one, okay. Then you need to give this one like this, okay, all 01, all those 103 columns, and you need to give it in the 2D form, okay, this one. Then just comma, then all the other things, then comma, all the other things, okay. So simple. So let me oops, yeah, but here it's already under that, so we don't need to give in the 2D form. Okay, simple. Now let's fine tune this. Okay, let's try to increase the accuracy hyperparameter with grid search CV. Okay, hyper tuning of DP. Let's do it. Okay, so let me tell you. Okay, so let me tell you how to do grid search CV, and I will tell you what is grid search and what is CV basically. Okay, the cross validation import grid search CV. Okay, okay. Now, what is grid search CV? See, let me tell you here also, here only. Okay, see, when you are training, okay, when you're training, see, if you press Shift plus Tab, it will show you in what parameters you want to train. Okay, like see, in decision tree you have Gini, and you have one more you have, okay, and you minimum sample sleep. Now in decision tree, what is sample sleep, what is sample split, and what is maximum depth, you search it. Okay, you learn about decision tree, you will get to know what is this maximum feature and what is
this one, this minimum impurity decrease, and also you can actually give the parameters on what parameters you want to train. Okay, maximum depth, what you want to have the maximum depth. Okay, yeah, criterion. Criterion. I hope I'm pronouncing right. By default, it's Gini. You can give entropy also. Now, what is Gini and what is entropy in decision tree classifier? You learn about decision tree classifier, you will get to know. Okay, I told you the basics of decision tree classifier, like it's a tree based like that. So you learn about that and you will get to know. Okay, now see, maximum sample split can be 10, 20, 30, whatever, right? Criterion will be Gini or entropy. Okay, maximum simple sleep, random states, something like maximum depth. So understand that you just can't put parameter, you just can't change parameters every time and train and check the results. Okay, it's gonna take a lot of time. Okay, because for first you're gonna check for, let's say, this parameters. Okay, then for the second time, then after testing on accuracy, testing on X test data, and then you're gonna check the accuracy, then you're gonna change the parameters, and then again you're gonna do it, then again you're gonna change the parameter, and then again you're gonna do it and check the accuracy, it is increasing or not. So see, you don't want to do this, right? It's gonna take a lot of time. So basically what we do is, there is a term called grid search CV. Okay, so what grid search CV gonna do, it's gonna, when you give the parameters here, okay, in under this, and you train, it's gonna train on every parameter and give you the best parameter to to train. Basically, of course, it's gonna train on the every parameter. Okay, it's gonna train on every parameter here. Okay, and then it's gonna give you the best parameter that it found, basically. Okay, after training it on the data. So let's do it and see how to actually you can do it. Okay, classification tree, I'm giving it the name, and how to call, okay, I'm calling the decision tree classifier again. Okay, and now C classification is equals to C one matter grid search. We have not given parameters. Okay, we will give, don't worry. But first you need to write like what is your classifier, this, then the parameters we will write. Okay, just hold on, and what is CV, I'm going to explain. Okay, these two let's write. So parameters is equals to, what is your parameters? Basically, see, under dictionary you need to write. Okay, now see, for decision tree classifier you have a lot of parameters. Okay, I'm gonna choose, I wanna experiment with criterion. I hope I'm pronouncing right. Maximum depth, and I wanna choose this minimum sample split. Okay, now you can experiment with as much as you want, means the parameters which is available. Minimum samples split. Now in a range, let's say 10 to 500. Okay, and if you want, like you can distribute it, you can, if you know the range function, how does it work? Okay, it's like a step of every 10 at every 10. Okay, or every 20, something like that. Okay, so in my previous project, like I was doing, I given 20. So okay, if you just understand the range function, like it will go in a step by step by 20. Okay, you can say from 10 to 500. Maximum depth, I wanna give depth and even if you don't want to give, that's all right. Okay, but it's gonna take little much more time to train. I'm skipping every 20 step, you can say. It's not skipping, basically, I don't know what to say. Like, see, here you will understand. Okay, maximum depth you want the range of 1 to 20 to 2. Okay, so see, it's gonna go like 2, 4, 3, 6, 8, 10. So, and basically like this. Okay, 20, 40, 60, 80 till 500. Okay, in a step function. And the criterion I'm gonna give criterion. I'm gonna give, let's say, what is this in a list? The first one, that is by default one, Guinea, and the second one, and copy. Okay, now parameters are completed. So I've given parameter. Now what is cross-fold? Okay, means what is cross validation, or not 5 basically. See, what is this? Okay, see, you have your data, let's say for training. Okay, what it does is basically, if like, see, you can even give more parameters of cross-fold, but okay, all right. What is CV basically is, if you give, CV is equals to 5, okay, it's gonna, this is your training data. Okay, so in the first, when it's gonna train for the first time, okay, if you give CV is equals to 5, it's gonna train for first time, and it will split your data into 5 parts. Okay, and it's gonna train on the 4, and it's gonna test on the first. Yeah, and then again it's gonna train it for second time, your training data. It's gonna training in this 4 right now, and gonna use this one for the testing. Okay, test data is different, X test is different, but here it is testing on the training data. Okay, see, 1, 2, 3, 4. Now this 4, it's gonna give it for training, and this one is for testing. Then this 4, then this 4 it's gonna use for training, and the last one for testing, and then it's gonna give the training score. Okay, so you can say that you not only gonna test on the X test data, but you are training and testing on the training data also. Means, your performance gonna eventually, it might gonna improve basically. Okay, so we are using basically 2 parameters, 2 important functions to improve our accuracy: grid search, okay, to find the best parameter, and cross validation to test on the training set also. Okay, so means you not only finding the best parameter, you are training it in a much efficient way by testing it on the training data only. Okay, so CV is equals to 5, and I think I have given everything. Okay, now classifier dot fit. We're gonna train it on training data, and then we're gonna test it on test data later. Okay, I think I've given everything. I know. Okay, it's gonna take little time. It's gonna take much time only. Okay, so it took me around 5 minutes. Okay, it took me around 5 minutes to basically train. Okay, so let's find out the best parameter. First of all, you can see here. Okay, it is saying that it has all this. It is first of all showing the parameters, not these parameters which we gave, but the default parameters, and then the parameters we gave. Okay, and let's check the you can say the best parameter. Okay, what it found basically is this. Classification dot best estimator. Okay, yeah, okay, and see maximum depth 11. Okay, minimum sample split we had to give 90. Okay, by default it takes sample split 2. Okay, we need to give 90, maximum depth 11. Okay, by default it takes where none. Okay, it doesn't take anything. And then where it is criteria gaining. Okay, so let's test this on test data. Okay, we trained it on training data now. Let's test this one on the test data. Classification predict on X test. Okay, and see let me store this in a variable dt grid. Okay, I'm just storing this just so that I can check the accuracy score of this classification. Sorry, dt grid. Let me change my name because I think I'm gonna get confused. Not my name, classification predict. Okay, because dt I've already used before. I think predict. Yeah, I'm just changing name so that I just don't get confused later on. So, predict with y test, with the real y test. Okay, we train it on X test. Let's compare. See, 84% accuracy, and when we trained it without without that without giving parameters, by default 81%. Okay, so now what you can do is basically you can change the parameters. Okay, there also sleep 90, maximum depth 11, and criteria Guinea, which it is by default there. Okay, so you don't need to, but still so see now you can give. See, it has the parameters to give now, so now you can give like this. Okay, here, and you can see. Okay, but the thing is accuracy will change now. Why? Because I think it's gonna change. I think so. Let's see, let's check. Okay, 86% on this is the training accuracy. Okay, this one was test accuracy 84%. Okay, see, the score extend vital and wait, y test and what basis I predicted. Okay, extend data. I don't need this, of course. And see, I predicted on X test data, and let's check the accuracy. 85%. Okay, 85%. Okay, so it's 85%. I deleted that X test. Okay, sorry, I just deleted. Okay, so see, now this one, earlier it was around 81%, right? Now it's 85% accurate. So means if you change the parameters, accuracy will be changed. So this is the best parameter you can train your model with decision tree. Okay, so basically this is called hyper tuning method, because you are tuning your parameters, you are tuning your models to give you best output. Okay, so what you tuned, you just you experimented with different parameters to get the best parameter to train. Okay, and to get the best accuracy. This was all about decision tree. Logistic regression, the last one. Okay, we're gonna use logistic regression and then we're gonna hyper tune this also. Okay, so what is logistic regression? A very simple model. See, it's just, you can say, first read this in statistic. Okay, the very important thing in data science, the logistic model, and of course in machine learning, the logistic model is used to model the probability of a certain class or event existing, such as pass, fail, win, loss, alive, dead, or healthy, sick. Okay, see, this basically works, you can say, in the probability function. Okay, like see, in a probability manner. If you just see this, okay, let's say it's this class is for cats and this class is for dogs. Okay, 50%. So if the model thinks, that you can say, if the model thinks that if you give an image of dog and model thinks that the probability of that image is a dog, then that threshold will cross like this. Okay, 50%. This line will cross like this. Okay, and it will give you output as dog. But if the model thinks that only 30% are the chances that that image you have given as input is a dog. Okay, so this line will not cross this threshold value and your output will be 0 or not dog or whatever you say. Okay, it's that simple. It just works on this probability function. Okay, like see, in the logistic model, this is the formula. Okay, so if that if that output crosses a certain threshold value, the graph will go like this. Okay, ignore this blue line right now, and let me check if I can give you a better example. Okay, see this. Okay, it's again simple. If that the model thinks that if you give to test, okay, if you give any image or if you give anything to test, the model thinks it is probably that image or that input is it belongs to class 1, and it thinks that if it belongs to class 1 means, of course, the model is sure more than 50%. Okay, then the graph will go like this and your output will be 1. Otherwise if that input, and if the model is not 50%, even the 50%, if the model is not even 50% sure, then the graph will not go like this and your output will be 0. Okay, or not 1, basically you can say. Okay, it's that simple. Now that was about logistic regression. Let's apply logistic regression. Is simple. Log, I'm just naming it log. Okay, sorry, from sk dot okay, so from sklearn, it's dot basically it's okay, linear model info logistic regression. Okay, now log is equals to, that's how you basically apply this. Okay, now log dot fit let me just fit on x train data, means train on the x train data, and yeah, of course, and we're gonna see the result here. Okay, let's we trained it and see the default parameters it uses. Okay, you have many parameters to give. Penalty by default it's L2, and you can see C is equals to 1 by default, and class weight, random state, maximum iteration. Okay, multi-class solver. What is the solver? When you learn about logistic regression, you will get to know different kind of solver. Okay, I expect you to go through this everything, multi-class and maximum iteration 100 and all. Okay, so let's see the result basically. Okay, let's test this on log test is equals to, I'm just naming it like the log dot predict on x test data, and I wanna see the result. See, of course, see the result has come. It's of course it's if you get to know x test has 2000 around 2000 rows. So of course you cannot see, but let's check the accuracy score. Accuracy score is basically log test with your y test. Okay, you test it on x test data. Let's compare it with its level, how much it got correctly based on the truth one. Okay, the ground one, 84%. 84% logistic regression is giving us the accuracy score. Okay, alright. Let's check the training data now. Training log dot. Do you have a score? Of course, score. Can you check? I don't know. Yeah, we can check, but not like this. Okay. Oh, log dot score and score of X train with Y train. Okay, and let me print this out. 84% is the training score, and of course we want to see this training score. This one parameter this, and this is the testing score. 84% 77. This is 84.65. Okay, let's go for the grid search CV. Means let's tune this one. Okay, let's experiment this with experiment. It's, you can say, parameters. Why I took so much time to say parameters? And one more thing, just like I did here now, like this, I checked it on the manually on row by row. Okay, on a particular row you can do it like this. Okay, you can basically dt.predict on. Let's do it now. Here, let me show you what it says. Dt, it's not dt, it's log. It is showing C. Okay, in the decision tree it was 1. Okay, but see, in the logistic regression we are saying 0 means, and what we know in decision tree, basically in the third one it's basically 0, right? What is 2 3 basically? Okay, forgot. But see, it's in the decision tree it showed 1, and see, in the logistic regression it is showing 0, and this one is correct. Okay, and of course accuracy score is better in logistic regression for this data set. Okay, that doesn't mean logistic regression is better on everything, but model's accuracy changes with every data set. So let's go for okay, so model, I'm giving different name here. Model, what is our model? Logistic regression. Okay, and solvers. If I want you to go through the some theory of logistic regression. I just showed you the basics one. LB basic one means how logistic regression works and how decision tree works. Linear. Okay, these are the solvers. By default, it has solver 1. Hey, we don't have 1. The penalty. Okay, penalty is, so we're gonna give penalty L1 and L2. Okay, by default it took L2 as values is just C values. 110 means it's gonna experiment with this one. 0.1 0.01 0.001. Okay, let me give some space so that you understood it well, even I, just to see clearly. Model will understand, of course. So these are our parameters. Let's parameters. I hope my spelling is right. Okay, parameters is basically, of course, it's simple. We just need to parameters. It's simple. See, we need to give it on dictionary form. So dictionary, it will convert it into dictionary. I'll show you. Solvers. Okay, and penalty is equals to penalty is equals to penalty, and then C C values is equals to C values. Okay, let's run this and let me show you what is the parameter C. Okay, like this it converted. Okay, like this. So okay, let's call this grid search log, naming it like this. Now grid search CV estimator. What is our estimator? Model. Estimator is equals to model. Parameter grid is equals to our these parameters. Okay, and anything else? CV. Of course, CV is equals to what I have given CV. CV is equals to 5. We're gonna give oops. And do I need to give anything else? No. Okay, let me edit this one. And anything else I gave it in here? Of course, this one. How can I forget this? Log. So this. Let's train it on this, and let's. Oh my god. Invalid parameter. Oh my god, how? Oh, okay. Forget. It's not C values, it's basically C. Wait. Yeah, it's C, okay? It's not that, it's C basically. And now let's what I'm doing wrong is basically 110, 0.1, 0.01, 0.001. It's good. C values is okay. Parameters, dictionary, solvers, penalty, C is equals to C values. Okay guys, so after wasting 30 minutes, I found it. This should not be S here. Because parameters, the parameter in the logistic regression have solver, not solvers. Please don't say 12 or non-penalties got L1 only. What? So it is saying that solver Newton CG supports only L2 or non-penalties got L1 penalty. Let's see. So I think we need to remove this L1 to work on the Newton CG also. Okay, well, penalty either should be L1 or L2. You can experiment this by removing Newton CG and putting L1 here. Okay, so let it run, and it's gonna take 2-3 minutes. I'm gonna pause this. So this one is saying that LBFGS failed to converge increase the number of iterations. Okay, see, this is showing us increase the number of iterations. Why? Because convergence warning, LBFGS failed to converge. Okay, see, increase the number of iterations. The default iteration is 100. Okay, let's try for 1000. Okay, so after finding out, like, see, iteration, see, what is the iteration value? Okay, by default it is 100. Okay, maximum iteration 100. And what it is saying is convergence warning, LBFGS failed to converge, increase the number of iterations. So we just need to increase it. We need to increase it here. Okay, here it means don't write here, okay, in the parameters, because it's a parameter and it will take it as a string. Okay, if you run this now, see, if you write like this, okay, if you write like this, so see parameters, okay, see solver, and see it is taking it as a string, okay, and max iteration is not a string and it will give you error, okay, a basic thing which I am showing right now. So write it here, and maximum iteration we have given 1000, okay. Now we have increased the number of iteration. Let's run this. Let's wait. Okay, so everything is done, and see, and now let's go for the best parameter. Grade search log dot, see all these things, and we just need to be best params, best estimators, of course. What does best parameters contains? I need to see. I want to see. Best parameter basically is Newton CG, and where it is C100 we need to give, and what one more we gave now, penalty, of course, that's L2 basically. Best, I need to see best, what the best parameters, because best estimator is showing best, okay, of course it is showing everything, and these are the best parameters: C100, penalty L2, and solver Newton CG, okay. Now let's test this on test data, okay, dot predict on the X test, and let's compare the accuracy score of this. Let me store this somewhere, is grade log, okay, and grade log, we're going to compare it with our real data. 84%, not much increase in accuracy, and we applied key fold, we applied, yeah, C fold, okay. So basically you can give penalty 12 C100. Now what you can do is basically you can just come here and you can see, okay, it's not 12, sorry, penalty L2, by default it is there, L2. C you can give, C is equals to 100 you can give, okay, and what is that, solver, okay, solver is equals to this you can give now, Newton CG, okay, Newton CG, solver is equals to Newton CG. Other, it will be by default, okay, by default other parameters will be there like penalty L2, right? Let's test. Now let's see the training score. Earlier it was 84%, right? Okay, not much increase in this. 84, it's increasing just with little bit, okay. So that's how you can hyper tune your models. I did it for decision tree and logistic regression. That's all. Okay. So if you found this video useful, like, subscribe to my channel, hit the bell icon. This was the last project on data science classification, at least this year. And then now we're gonna start regression projects like stock market prediction. 2 regression projects coming, and then from September, machine learning from scratch. Okay. So like this video, subscribe to my channel, hit the bell icon. Bye bye. See you next week.